Alrighty here, so let's do an indefinite integration problem in our calculus journey that we're taking here. Before we get started, if you are shaky on the difference between definite versus indefinite integrals, go ahead and check out a video I have on this playlist of my channel called Integrals Definite versus Indefinite or something along those lines, and that will clear up any confusion, hopefully, on what we're talking about. A quick recap for the purposes of this video related to indefinite integration. An indefinite integral is simply an integral where we do not care about an interval, and we're taking a function, dx, and then we're going to spit out another function, and this function right here is the antiderivative of this function right here. Now, what does this mean? What does antiderivative mean? Oh man, nice quotation marks. Alright, what does antiderivative mean? Antiderivative just means you've got a function, some function, let's see, we have f of x here, and you want to know what function, when I take its prime, gives me f of x. So this is saying, what function can I take the derivative of, and the derivative is f of x. So that's all this is saying, indefinite integration. So indefinite integration means exactly the same thing as antiderivative, if you're asked to evaluate or take the antiderivative of a function. So let's go ahead and get started here. The function I would like for us to evaluate is the indefinite integral of x plus 1. Let's make that a little bit better. X plus 1, x squared plus 3 dx. Alright, now these are there are two different little expressions in here, so yikes, what do we do? I think that, well, we could do several things. There's a ton of options, but I want to make this as easy as possible. So we could say, okay, what's this? Let's evaluate this. Then let's evaluate this. Use the product rule. That's horrible. Let's just pass. Let's just go back and do some simple algebra. I think that's often a really good idea. If you can do a simple algebraic maneuver to skirt around something that's difficult in a problem like this or would otherwise be unwieldy, go for that. So let's do that. So let's combine these things. Let's just FOIL them out, basically. At this point, I think we should be able to do that pretty easily, so I'm not going to worry about explaining all the steps there. So let's just look at what we would get. So we multiply these two things together, blah, 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 each expression times each expression, and term by term, and we're going to end up with x cubed plus 3x plus x squared plus 3 dx. Alright, so like I said, we're going to be doing a simple third degree polynomial function here. Alright, so we've got this, and this is great. This is the one we're going to be working with from here on out. So let's go ahead and talk about the next best step. So if we have this integral of all these little things, and it's just these things being added together, well, if I'm just taking the derivative of something, if I want 6x plus x squared prime, well, this is the same thing as 6x prime plus x squared prime, right? Yeah, of course it is. So this is the same thing. We can break these things apart using like a sum rule here. So let's go ahead and do that. Let's make this a lot easier on ourselves. So what we're going to end up getting is, and man, I wish this eraser was larger so it wouldn't take up so much time. Alright, here we go. So let's break this up. So we're going to take all of this, and we're going to get the indefinite integral of x cubed dx plus the indefinite integral of 3x dx plus the indefinite integral of x squared dx plus the indefinite integral of 3 dx. So this is our new thing to work with. So we're going to keep flipping back and forth between this page. So let's look at first Let's look at this right here. The indefinite integral of x cubed dx. Well, remember, if you've seen some of my other videos, you might remember this neat little formula here. This is crazy awesome and useful. If we have something raised to a power, x raised to a power, we can figure out the indefinite integral of it crazy easy by just doing this. Even if there's a coefficient in front of x, because in this case, look, there is a coefficient in front of x. What is it? It's 1, right? It's just an understood 1. So here is the rule we're going to have to follow, which is, make that line here. Our rule is going to be that x to the nth power, the indefinite integral, yikes, get a little bit ahead of myself, don't I? The indefinite integral of x to the nth power dx is just equal to, and look how easy and awesome this is, x to the n plus 1 power over n plus 1. That's it. It's that easy. So, what is n? N is the power it's raised to. So, let's evaluate this first little piece right here. Let's go on to this next page. X, the indefinite integral of x cubed dx. Let's just use that rule. We're going to get that this is x to the 4th over 4, right? Because 3 plus 1 is 4, 3 plus 1 is 4. So that's all we have is x to the 4th plus 4. All right, now what were we looking at? We're looking at the indefinite integral of 3x dx. So plus indefinite integral 3x dx. So let's go down, and what are we going to do here? Well, this x does have an exponent. It is raised to a power. 3x is the same thing as 3x to the first power, right? Yes, of course it is. This is good. So we're just going to use the same rule we used over here and end up with plus 3x squared over 2, because 1 plus 1. So that's all we have to do there. Those two are pretty easy, right? So now our next is, let's see here. Oh, yikes, eraser, wrong thing, is x squared, the indefinite integral of x squared. I'm going to go and kill all these ugly circles. Let's do that. All right, so we have plus x squared up here, plus the indefinite integral of x squared dx. What's this going to turn into? Well, using that same rule, we should be getting a little bit faster at this, x cubed over 3. So a good way to think of this also is whatever you stuck up here, you're sticking it down there. Same deal. So now I think we only have one thing left, which is, yep, that's it, the indefinite integral of 3. Now, this should be easy to think about in your head, because what is, hang on, I'm sorry. All right, there we go. What is, we have indefinite integral plus the indefinite integral of 3 dx. What is going to give us just 3 when we take its prime? Well, let's think about it this way. What is this rule? Constant times a function prime is what? Well, it's the constant times f prime, right? Yes, of course it is. So an example of this would be 6x prime equals 6, the constant, times x prime, which is just 1, so it's just 6. So this works on the same premise. What is going to give us the 3 when we take its derivative? Well, using the constant times the function rule, we can, use some reverse engineering here and deduce that it's just going to be 3x. So this is plus 3x right here. So we have successfully taken this, we have turned it into this, we've broken it up into this, and now we've evaluated it into all of this. So that's great. I mean, we've made a lot of progress. So we have this final answer here. But this is wrong. This is not okay. What do we need to do? Well, if you've seen my other videos, you'll know that there has to be a C on the end. And a really quick explanation of this is, what is C prime? It's always 0. 100% of the time, is it going to be 0? So, yes, it is. So, it's going to be 0. So, because we add a C on the end because this expression right here could have any constant we wanted tacked onto the end of it. If it was all of this plus 6 or 17 or negative 34.6, it would, all of these would, when you take their prime, give you a 0, so it wouldn't change the function. So you have to put that plus C on there. Now, I know you're thinking to yourself, but what if this indefinite integral in real life, what if it doesn't have a constant on the end? What if there's nothing? Well, then C would just equal 0, because 0 prime, 0 is a constant. 0 prime is also 0, it's itself. So, which is a really cool thing about 0, is that its own derivative, just like 0 is its own derivative, like e to the x is its own derivative. So, all right, that's all we have to do, and this right here, my friends, is our final answer. So, we're done.